Hello, everyone. I hope you're enjoying the data conference. I am Troy Gatchell, CTO of our data and AI practice in the innovation team of HCL Software. I want to welcome you today in our discussion of Actian Vector with Tensorflow and Google Marketing Platform equals Marketing Tech Hero. And the purpose of my presentation is twofold. One is to give technical audience an understanding of the technology and what you can do to utilize Vector, TensorFlow, and Google datasets to solve business problems. And we're going to go through a specific business use case that will help your marketing teams and help your e-commerce teams activate audiences, activate recommendations to audiences. And second is, for business users that attended the conference, understand some of the technology that can accelerate solving some of your business problems around marketing activation and media activation. And the use case I'm going to go through today, you can utilize this technology and the data sets, and you don't need a marketing agency to do it. You don't need a media agency to do it. You can do it with your own first-party data and your own technology. So the objectives today, I'm going to go through a solution overview of the technology and the data. I'm going to go over what is Actian Vector, the architecture of Actian Vector, and why we're using that to power our data science activities. A brief overview of some Google marketing data sets that you can utilize and ingest into Vector for your data science models. And then I'm going to take all those data sets and explain collaborative filtering with TensorFlow and how we do content or product recommendations and how to connect that back into the Google Marketing Platform. And finally, taking all these things that we learned today and how you can get started on your own right after this session. So today's use case, we're going to take a sample of, let's say, Google Analytics, Actian Vector database. So we're going to ingest a data set, or I ingest data sets into Actian Vector. And then on top of that, we use data science libraries, TensorFlow, produced by Google, to create our models, to create our recommendations, and then finally, how to push that into Google Customer Match. So Google Customer Match is within the Google Ads platform, allows you to use first-party matching techniques to push retargeting or upselling or even removal from campaigns based on your first-party data and reaching audiences within the Google ecosystem. From a technology perspective, how we power our commerce and our Unica platforms for these types of activations is bringing in the analytics and media data from the Google platform. So Google Analytics, Google Ads, YouTube, pushing that into HCL Vector, analytical warehouse. And then on top of that, you can utilize your favorite BI tool. I have Looker here, and we utilize Looker quite a bit. Your Jupyter Lab notebook connecting to HCL Vector and TensorFlow libraries to power your data science models. We also have access to commerce data. So a lot of our clients are on our e-commerce platform. So we utilize an open source ETL tool called Apache NiFi to stream and batch that data into Vector. So we can get near real-time analytics to our dashboards. We can get real-time data science activities and batching that data, and then pushing that into our scores and model scores into a cache mechanism that our commerce platform can utilize for personalization. Unica, that my colleague Mark Greiner is talking about, can utilize that data for marketing automation, campaign automation. It's really about the scalability of the analytics warehouse and why we chose Vector as our main warehouses, because one, it can still scale horizontally, it can scale vertically, and it gives us the power to put all these data sets into one place and really utilize that to make decisions. With HCL, we are also partnered with Google quite closely in the Google Cloud perspective. And one of the things that we utilize is all the Google marketing data sets into one profile for the user. So if you picture Google display ads or AdWords, when people are searching for a product and they click on an ad in Google and they go into a landing page, those types of impressions are captured, and we can bring that data into Vector. We can also bring in the Google Analytics data. So that's your site analytics, your tag data. So when people are browsing the site, adding items to the cart, removing things to the cart, abandoning cart, all those activities are recorded by Google Analytics, and we ingest those into Vector. And then also, if you can think about all your other social media data, Facebook segment data, LiveRamp from an identity perspective, bringing in different demographics into your profile, and then POS and offline data, bringing all that data into that warehouse as well. And what that does is we have all those raw data sets in one warehouse, Actian Vector, and then we're able to process those things to create a profile and attributes about a user, attributes about a segment, and then run data science on that to understand what products, what content should we recommend to them, what's the right message, what's the right tone, and those types of things to activate into the different platforms of our commerce platform and our Unica platform. And then finally, other media platforms like Google Ads. So a little bit about Actian Vector and why we chose it. It's a modern data warehouse. So some of the aspects or features of it is you can both store structured and semi-structured data. So it supports JSON documents, flat CSV files, all those types of structured data sets. It's very easy to integrate a variety of sources. Many ETL tools can connect to Vector through ODBC or JDBC. It also has connectors back into Spark where you can do external tables. So you can take advantage of your Hadoop ecosystem, whether that's on-prem or in the cloud. And one of the things I think that's very important is the ad hoc performance at a very high volume that you get out of Vector. So it allows your business users or your users to ask more questions because they get their answers faster. Instead of running a query and waiting 30 minutes, 40 minutes, hour waiting for the results, you get results quicker because of how Vector structures your data in a compressed format, which we'll go through in a minute. And then scalability. So as you add data volume, terabytes and terabytes of data, Vector scales with that data. Then high concurrent user load. Unlike something like Redshift where you have to balance data coming in versus who's reading that data, and you have to do a lot of things at night not to interrupt your reporting users, that doesn't happen with Vector. You can have concurrent user loads reading your data while you're doing live updates to your data as well, because the mechanism that it does underneath the engine of bringing in real data into the log, into memory, while people are querying it. And you don't get that locking, you don't get those types of things that you have with other warehouses. And then for some clients, it's very important from a hybrid deployment flexibility. So you'll be able to do on-prem, be able to do your cloud of choice. We use Google Cloud compute engines for Vector and quickly deploy those through Docker containers to get them up and running in our environments. And with all that, it creates a lower total cost of ownership. And just some metrics here. So from a data size perspective, you can store from 1 to 500 terabytes. You get sub-second query response time based on the compression algorithms and the second generation columnar that we'll go over. And then concurrency, like I mentioned before, you can have tens to hundreds of users at once querying data. You can have your batch or streaming data coming into the platform without large interruptions to your user. As I mentioned, easy to deploy and manage. You can deploy it through Docker containers. You can have Linux versions. You can have Windows. You can build it on top of your Hadoop ecosystem. So really improving your Hadoop performance and any public cloud of choice. It also has standard SQL. So your business users can use it. Your data users or analysts can use it. It also has strong support in UDFs from SQL, JavaScript, and Python. And as I mentioned earlier, it has strong Spark connectivity for external tables. So you can have your Spark jobs and then read them in Vector, or have a job from Spectre and push it into Vector for really fast query response time. And then it has encryption and enterprise management. So you can do dynamic data massing. You have encryption at rest and in motion. And all this data is stored in memory and columnar based, which we'll go through next. So one of the things that's different about Vector and other databases, if you're running your warehouses on typical RDMS like SQL Server, Oracle, or MySQL, those are very row-oriented data sets. So what that means is data is stored at disk by row. So if you see this example here, all those rows are stored together at disk, and it makes it very hard to aggregate that data when you're trying to do aggregations like this example of summing the revenue for sales of t-shirt and grouping by date. So what other warehouse services started doing was building out a columnar database to kind of bring that data together. And you have a little bit less filtering and summing on that, but that's still not fast for masses amount of data. What Vector does is it really groups like relevant data together. So in this example, you have the date June 2nd, you have t-shirt, and it has all those revenue numbers in that. And then the same thing with pants. So when you're doing these types of queries, it compresses that data in memory, and it's really fast to get aggregations, really fast to get analytics. And then when you're doing feature engineering from a data science perspective, having all this, your features grouped together makes that extremely fast for your notebooks. Instead of bringing that data into Python and waiting for it, you can issue those queries to Vector, and you'll get your features back in relatively short order. So from a Google dataset perspective, with Google Analytics 4, they have released new retail and e-commerce events that we're utilizing on our client sites for site analytics. And this is just a very small example of that, but you can capture almost any retail or e-commerce event that you can imagine. So adding to cart, you can see if someone's viewing the item, you can see if someone removing the cart, looking at order details. So you have a real in-depth knowledge of how people are clicking on your site. You can also capture where they're referring from. So say if you're running ads on Facebook or Google, and they're clicking through into your sites, you can see where that page is coming from, because maybe you want to personalize that experience with that referrer. You can also understand what geo they're coming from as well, if a location-based is available on that. So you can see what cities or what geo areas and be able to personalize on that. And so I recommend taking a look at Google Analytics 4. They also have the GTM server side now, so you can stream all these things to the server, and you can automatically push those things into Actian Vector in more real time for even faster analytics and faster data science mechanisms and pipelines. Within our environment, we have Google Analytics 4 and commerce data. So we have a logged in user or a guest user, and we're able to understand those data sets and join based on cart basket or user IDs back into the commerce data. So then we can start overlaying what the product categories are, what the product colors, or what the shipping information is to that data. So now we have site analytics matched with conversion data of commerce data sets that allow us to help us inform new data science models on content and recommendations for both logged in users and guest users. We utilize two types of machine learning models. One is content-based filtering. So we use a Python scikit-learning. What content-based filtering allows us to do is based on past content interactions or past interaction with products, we can have an unknown user come in and start clicking around on products and content. And based on those actions of previous users, we can understand what recommendations we should make for that user. So say if a user goes in and buys a sports team apparel shirt, hey, a similar category is also a sports hat. So we're going to recommend that into when they add to cart, we're like, hey, this is a similar item that other people were also bought. So you don't even need a logged in person to do that or know who that person is. You can just do that by past behaviors and utilize content-based filtering for that. The other way we do this is through Tensorflow's collaborative filtering mechanism. So this allows you to understand similar users and how they interact. So here we have user A and B. They're similar users, and they all both bought the same shirt. And that user A also bought a hat. So we would recommend that hat to user B because they are similar users. And with the power of deep learning framework, you can do multiple branches and multiple labels and layers of what these products are and get more sophistication. So for example, you could add in a layer of shirt and color and hat color and those types of things. The model starts learning those types of different layers, and then they can even get more precise recommendations for similar users that bought those things. And then what we do is we combine those types of scores into a hybrid model and then start doing top recommendations back into either a commerce personalization engine, or I'm going to show you here in a minute how we would utilize Google Ads to do retargeting. So kind of bringing it together here, we have a vector table with all these features. Features for our models can be 10 columns, could be 20 columns, could be a lot of different features that the model's in. And this is obviously a small table here, but think of millions of interactions on a website for a large scale retailer. You have 1 million clicks a day, those types of things. So that data really adds up. So that's why we use a scalable data infrastructure underneath, like Vector. Then you put TensorFlow models on it that I just went through on the content and collaborating. And then those things output a score. This is a minimal version of that. So, we're going to recommend to this user a black hat. We're going to recommend this user a My Team jacket based on our models that we went through. And how do you activate that? So one, you could do that through a personalization engine on a website. We have Unica Interact that allows you to do offers. So my colleague Mark will go through how that is done in Unica and back into our commerce platform. And what I mentioned earlier was Google Customer Match. So what you could do, say user ID is actually an email because Google Customer Match wants email. You could retarget these users for upsell them on different products. Google will take that data, match it in a privacy safe way, and display your campaign ads in their ecosystem. So that could be a user's Gmail. It could be a display ad that the user sees in Chrome or a YouTube video if you have video campaigns. The other way to use it is powering lookalike audiences, and your marketer or your e-commerce executive wants to take their high value customers and target more people like them to sell more and convert more. So you can utilize those models that I just went through, understand who are high value customers, and then send that to Google Customer Match and say, hey, I want to target these sports apparel campaigns to these types of audiences. And Google will be able to do that. The other use case I mentioned earlier was, say you already have a conversion for a user and you don't want that person to see an ad anymore. You can remove that user from your customer list. And so they won't see those ads anymore, which also saves, one, it's optimizing your ad cost spend. And two, it's targeting the people that you want, and it's targeting people that you want to come back to your site. So how to get started? You can go on this website here and download the Vector Community Edition. You have a 100 gig limit for that. I recommend, if you're not familiar with collaborative filtering, to practice with the movie lens data. So once you have Vector installed, you can easily ingest that data into Vector. There's Python sample code in the practice movie lens data that you can utilize, connect to the vector database to bring that data into your model and practice with it. And then you can go on to taking that similar model and doing your type of use case that you want to do recommendations on. The Google Customer Match Guide is here on how to utilize that. And I think it showed how to use the scalable technology, building out from the Google marketing standpoint and helping solve some of the use cases that I see marketers want all the time and e-commerce executives want all the time on how do you activate on audiences? How do you get the right message? How do you get the right target audience? And we went through that today. So I appreciate everyone's time in going through that. I'm happy to answer any questions along the way, and don't forget to connect to have a deeper discussion either through our HCL virtual booth or connecting with me on LinkedIn or through email. And thank you for your time.